Okay, let's start. Our topic for today are unit tests. Unit testing means that we automate tests. We don't want to do the testing manually because that's a very boring task, but we would like to do the tests in an automatic fashion so that we can repeat them over and over and over again. And whenever we change something in our application or when we add some functionality, we know that we didn't break something else. Because it's very embarrassing. If you have software, you ship it to your customer, you have a bug in that software, you fix the bug, and next time you ship the software, you introduce the same bug again. Customers typically don't like that. Of course they don't. We call this a regression bug. And bugs like this can be prevented by doing automated testing. Because manual testing, we all know, as developers, we are sometimes a little bit boring when it comes to testing. So therefore, we would like to automate all this stuff. The technique here is not fixing bugs, but preventing bugs. Writing software in a way and with tools that prevent bugs in the first run instead of fixing those bugs manually and having to struggle with customers. Okay, let me show you how that works with Angular. Angular comes with unit tests built in, and I have prepared, oops, here it is. An empty Angular application here. It's completely empty. It was just an ng new. That's all I did. And see what's going to happen if I open that in Visual Studio Code and I just run npm test. If I run npm test, the application is compiled. And after the application has been successfully compiled, the browser is automatically opened. So I don't need to open Chrome manually. It just spins up and runs the tests in the browser, and I will see the result in Visual Studio Code. Ideally, you have two monitors. On one monitor, you have the tests running. Here you see that we currently have 3 tests, and all of them are successful. We have no bugs. And down here, you see the output of your application. So what the test does, it really runs your application and then perform some automated tests. This is what this testing does. So remember, simply run npm test and then the test run, and here you should see the result. Let's break something. The generated tests are really very, very basic. There is one test inside the generated code that checks for welcome to something. And if I misspell something, let's do a second O here and run it again, you see the tests are executed automatically without me having to refresh anything. Whenever I change something, the tests are run automatically. And this is meant with frequent automated testing. That means whenever I change something, a nice little software robot sits on my shoulder and tests the whole software and gives me feedback whether I've broken something. And in this case, I get the message that here, welcome to Jasmine intro does not contain welcome to Jasmine intro. So we have introduced a bug. So now we can fix the bug, remove the O, save it again. The tests will run automatically. They will run in the browser. Of course, we could use different browsers. If we primarily use Firefox, or we would like to run the tests in 3 different browsers, that's absolutely no problem. The tests can also run on mobile browsers, on your iPad, on your, Chrome, on any kind of Android. It doesn't matter. You should make sure that your tests are always green. Okay? So let's take a look how we write those tests. I will focus on the kind of tests that are relevant for your exam. In your homework, in today's homework, you have more complex tests too, but don't worry, this is not part of the exam. So let's add some business logic. And in my case, I'm going to generate a so-called service. A service is just a class, okay? npx ng generate service, let's say circle math. Let's do a very simple service where we can input the radius of a circle and then we calculate the area of the circle. Radius multiplied by pi. R square pi. Good. Let's generate the service As I said, it's just generating a class, nothing special. Here you see, it's just generated a class. The only thing that's special with the service, I'm not sure if I mentioned Angular services before. The only thing that is special, this class is now magically available everywhere in your Angular application. That's the only difference. But at the end of the day, it's just a TypeScript class. And you see, here is the test. And we will work through this test in a minute. First, let's add some business logic. Very simple. Let's say we have a calculate circle area radius number. It returns a number, and we return radius multiplied by math.py. Good? Very, very simple. Now, let's try that. Let's take a look in the specification file here. The specification file that Angular created is, for our very simple case, unnecessarily complex. I can't delete this and I can't delete this. The only thing that remains are two lines, describe and this it statement. Describe is already part of Jasmine. Here you just say, I would like to describe a set of tests. It's like a headline for a test. If you can remember how this looked like, you see this one, here and here, just headlines for a number of tests. Just a descriptional text, anything that comes to your mind can be written here. And this one, you should read it as a full sentence. It should be created. This IT doesn't mean anything special, it's just the word it. So we could say, it should calculate the circle area correctly. It should calculate the circle's area correctly. And then, inside such a test, we can write any kind of code. And nearly every test has the same structure. We do some preparation, we execute some code, and at the end, check the results. It's always the same. So let's do the preparation. What do we do in the preparation in this simple case? We just create an instance of the class. Const math service equals to new circle math service. Now we could, if we have a more complex scenario, we could initialize some variables, maybe load some data, whatever we want. Then we execute something. Okay, const result equals to math service dot calculate circle area, and then we can specify a radius. And to make it simple, we just specify 1. Because as we know, 1 multiplied by 1 is 1, multiplied by math.py is math.py. Pi is the area of a circle with radius 1. Good. Now we can check the results. And here we use so-called expectations with Jasmine. We say expect result to be math.py. Get it? Expect result to be math.py. And that's a unit test. Let's save it and let's see whether it runs. It should run smoothly. Here, before we had 3 tests, see it here? Now we have 4 tests. Everything is good, everything is green, exactly as we want it. My tip for you is always write nearly passing tests at the beginning. Don't write passing tests, because now maybe you have written code that doesn't test anything. So what I typically do, I introduce a small mistake in my unit test. So for instance, I say 1.1, save it, and I make sure that the test fails. Every test that I write, I would like to see it failing before I move on. Okay? So in this case, the test fails. It's correct. It says, sorry, Rainer, what you specified is not true, because you expect that 3.8 something should be 3.1 something, and that's simply not the case. Good? Now, we can fix it. Okay, that would be trivial. Now we can fix it, and now we should Nice. Have a passing test again. That's good. But what if it's more complex? What if we introduce the bug in our software and we don't find the bug, we don't see it. We take a look at the code, we need to somehow find the root cause of the problem. The first tip that I can give you is you can add here, you can add a letter F like force, and if I save that one, all other tests are ignored. So you really focus on this one test. If I take a look in the browser, you see it ran only 1 out of 4 tests. Got it? So now our focus is on that test. And what we can now do is we can click on debug here. See it? Click debug, and that will open a new browser window. Here we can press F12 to get the browser debugger tools. Go to sources, and if you take a look here, where is it? Here? No, here, Webpack, sorry. Dot, source, app, and here you see your code. See that one? And now I can go, for instance, to my unit test. This is my unit test. I can set a breakpoint and just reload. If I reload, the browser will stop here, you see? I will zoom in a little bit so you see it a little bit better. And now I can, for instance, press F10. Okay, back again. Now let's not press F10, but here we have some buttons, you see that one? So we can press here, and now we can hover over it. It will tell me that it's 3.8, and I now maybe see what the problem is. Even if I keep running, let's run it and rerun it, I can step into my methods. So for instance, if I run it until here, step over, and then you see here, step into the function call. We are now calling our method calculate circle area. So I click here and the system jumps into the calculate circle area, and I can debug the code on that level, and with that I should be able to find the problem. Get the idea? Good. Let's run it through. Now imagine we have now found the problem. So we can go back, fix it, save it, tests will run automatically, and we are good to go. Very nice. Okay? Good? Questions so far? So what you should remember for the exam in 2 weeks is, if you generate anything with Angular, you always get these spec files. See that one? Here is the code, here is the spec, and the spec is the unit test. Angular always generates some unit tests for whatever you create. If you just want to write a simple test, then you need to know describe, you need to know it, and here inside of this method you write any arbitrary code. The important thing is that at the end you should do some expectations. Good? So, let's try a more complex sample. Let's go here and generate a second class. Let's say this is my graphic math. Okay, this will be a new class. It is generated. Now I call it graphic math. Here is graphic math. Yep. And inside of this graphic math function, I would like to be able to do the following logic. I give it a field, a public field, which I call circle radiuses, and it's of type number array, and it's an array. And then I have circle areas, it's a number array equals to array. And then I write a small function, calculate areas of all circles. Let me one thing make very clear. It is not very good design what I do here. Typically, I would say I get the circle radiuses here, a lot of them, and I return a lot of circle areas directly from this method. But now I would like to design it a little bit differently. I would like this method to iterate over all the radiuses and then write the result into circle areas. Get the idea? So typically I would design it differently, but for writing the test, this makes it a little bit more interesting. Got it? Good. So let's give it a try. So for const r of this dot circle radiuses. Good. At the beginning we say this dot circle areas. It's an empty array, and here we say push. Oh, sorry. This dot circle areas dot push. Good. And how do we calculate the radiuses of the circles? We could use the service that we had before, right? So this service should use another service. Get the idea? And I told you that if we take a look here, this circle is an Angular service. It's just like that. It's always the same up here. We will not go into the details. You could do different things here, but that's not the point. This thing is just magically available. We can ask for this service in the same way that we asked for an HTTP client. Can you remember? HTTP client, we just wrote private client : HTTP client. It's the same. Circle math. Please give me an instance of the circle math service class. That's all. I don't need to create it myself. Got it? Good. And then we just say this dot circle math dot calculate circle area r. Is this code clear? Difficult? No. Right? It's just an array, iterating over the array, nothing special. Good. Now, let's go back to our unit tests and see whether they still run. Good. Yes, currently they run. Looks good. But I told you that these tests for our purposes currently are a little bit overcomplicated, so we can get rid of that one, we can get rid of that one, and have just the describe and the it. Same structure as before. So let's try that. It should calculate areas of circles correctly. Good. What do we have? Prepare, execute, check. What do we have to do for preparing? For preparing this test? Well, we need to create an instance of the class that we would like to test. So, const graphic math service equals new graphic math service. And what does it get as a parameter? A new circle math service. Got it? Then let's fill the graphic math service with a bunch of radiuses. So graphic math service dot circle radiuses dot push 1, radius 1, and push 2. So now we would like to calculate the areas of two circles. The first circle has a radius of 1. The second circle has a radius of 2. Okay? Good? Good. Now let's execute the test. Graphic math service dot calculate areas of all circles. And at the end, we can do checks. And now I ask you, do you have ideas? What could we check? What would be a good expectation here? Expect. We can write multiple of them.
The first item in the graphic math service dot all areas is equal to pi.
Okay. The first item means index 0 to be math.py. I agree. Before that, I would check something else. Expect graphic math service dot circle areas dot length to be 2. You know what I mean? Before we check whether the result area contains the right amount of elements. So, yeah, I misspelled that one. And what else? Well, we can check the second circle. That's really very simple. And the second circle should be what? 2 multiplied by 2 multiplied by, right? Good. Let's check that one. Yes? That's good. Should calculate areas of, let's say, multiple circles correctly. That would be a nice test. But typically, you do not just write tests for the usual cases, but you also write tests for edge cases. I would like to give you an example. I copy this test because I'm lazy. Should handle empty input array correctly. So what I would do is I would create the graph math service, add nothing, execute the method, and expect that the result array should be empty. Get it? So I validate whether it can handle empty input arrays and will correctly deliver an empty output array. Good? Do you have any other idea about edge cases? Which edge cases we could test? We could, for instance, test or make sure that the graphic math service, when we new up an object, has an empty input array or things like that. You can think of different tests. How do you come up with these tests? Well, typically, in an ideal project, not typically, typically is the wrong word. Even in an ideal project, the end users, who are your customers, will give you the tests that you should implement. Understand what I mean? So they tell you, if I input that, that should be the result. If they tell you something like that, you should write that down in a unit test. That is called an acceptance criteria. You should always ask your customers that they give you acceptance criteria. You have a question?
Does Jasmine automatically detect all .spec.ts files, or does Angular write them in some files so that they are run?
Angular configures Jasmine in a way so that Jasmine automatically recognizes all files that have the extension .spec.ts. So Jasmine always looks for spec.ts if you configure it correctly, and Angular does that for you. Good? Well, we have one big problem with these two tests. They are not unit tests. Why aren't they unit tests? Because they are testing two things. A unit test typically tests one aspect of your application. In our case, graphic math service. But here we also have the circle math service. But we have separate tests for the circle math service. We don't need to over and over again test the circle math service. It's unnecessary runtime. We pay the performance cost and we don't want to pay that cost. Get the idea? So what we need in order to fix that is we need to be able to create a so-called mock, a mock object. Let me show you how that works. I will leave the first test here just so that we can compare the new version and the old version. The new version does something else. The circle math service, if we take a look what the circle math service does, by the way, this shortcut was Alt plus F12. If you press Alt plus F12, you don't jump into the other file, but the other file is displayed inline in your code. That's a very nice thing. It's called peek into definition. Maybe some of you haven't known this, this shortcut here. We have this method, calculate circle area. See, that's it. So what we can do is we can create a so-called spy. Jasmine calls that a spy. I do the following. I say const graphic math service mock equals object, and in this object I would like to refresh your mind, the member calculate circle area. So I just say calculate circle area is a Jasmine spy. Create spy. Unfortunately, in Jasmine, we have to give it the name a second time. I'm very sorry for that. Yeah, it's JavaScript. What should I say? This is how JavaScript works. So unfortunately, we have to give it here a second time. So we just say create spy and return 42. So what we can do is we can say, don't really call this method. Just return the fixed value 42. It doesn't matter what you get as input parameters. You always return 42. You know what I mean? We are simulating the return by creating a spy. Now, we can push 1, we can push 2, but we do not need to recap the business logic here because we know it's already implemented. This isn't a very good style. You know why? Because we repeat the business logic. Imagine that we would like to change the way we calculate the area of a circle. Okay, that's a very bad example because probably the way we calculate the area of a circle will not change in the near future. But I think if you use your imagination, you could come up with some business logic where the customer changes his mind. In our case, we have a customer who doesn't believe in science and he tells you, no, the calculation is wrong, we need to do something else. At the end of the day, if we change the business logic, we have to change all the tests. And therefore, we don't want to repeat the business logic over and over and over and again. But now, remember what we did. Now we always return 42. So we don't need to check the result anymore. Or if we want to check the result, we can just check for 42 because this is exactly what we specified up there. You know what I mean? Now we don't need this circle math service anymore. We can just say this is the graphic circle math service mock. Get it? Now we are just testing one thing. This is a unit test now. Additionally, we can check the following. We can say expect graphic math service mock dot calculate circle area dot to have been called twice. So the spy automatically counts how often the method was called and we can verify whether the system correctly called into our business logic. Get the idea? Let's try that. Just save it and take a look. If everything is okay, we should see 7 success. I was too slow. It already ran it. Now we should see it. Something is strange. Okay, let's restart this guy. If you close Chrome, Jasmine will restart Chrome automatically, and here you are, 7 success. That's exactly what we wanted to see. So this is what spies are all about. You create the spy, and instead of running the real method, you're just returning a false member, a dummy value. And you can mock everything with Jasmine. You can mock the HTTP client of Angular. You can even mock the time. You can say, Jasmine, start clock mocking. And if you, for instance, have business logic in your code that waits for 500 milliseconds, you can tell Jasmine, hey Jasmine, do so as if 500 milliseconds have been passed. But I don't wait 500 milliseconds. So Jasmine can manipulate the browser's clock. Jasmine can really do a lot of things in that area. This is just the tip of the iceberg, but I think you get the idea, right? Good. So you might wonder now, how can I learn this more about this, or if you prepare for your exam? I don't have anything in my slides about Jasmine. Why? Because there is a really nice summary of Jasmine. Just Google for Jasmine introduction, and that will bring you to this site. And this site, if I scroll down, has on the right-hand side descriptions, and on the left-hand side, a description, on the right-hand side code, and on the left-hand side, a description what this code does. So I can scroll down, and you will learn about different things. You see, expect, to be, and so on. And if you look for spies, for instance, you will see exactly what I told you now with spy on, and a little bit down there, you will also see create spy, and things like that. So the documentation of Jasmine is really, really nice. For your exam, you must be able to implement a unit test like this. This must not be a problem. You don't absolutely need to know that one. If you want to have a very good grade, probably you should understand how you do this create spy, okay? But this is the difference if you want to have a 3, a 2, or a 1, something like this. But just to pass the exam, spies are not absolutely necessary. But are they complex? No, they aren't, okay? Good. Yes. Now let's go into Angular. And from now on, it's hopefully interesting, but it's not relevant for your exam. It would be too heavy to do that in just 2 weeks. So the next thing that I show you, as I said, hopefully it's interesting, but it's not absolutely necessary to pass the exam. Let's change the HTML here. Let's do the following. Let's add an H1 here, and let's say this is a circle. Let's call it calculator. So, and let's continue and see what I did. I changed the HTML and suddenly a test broke. That's exactly what tests are for. The test told me, Rainer, you changed something, and now, yeah, the program does no longer work. Let's take a look what the program, I see, we had this welcome to. So we have to take a look at this one, and we will see that there is something like this. You see that one? To contain blah. Yeah? We can either delete this test, or if we don't want to delete this test, we can also put an X in front of it. Like F for force is X and exclude. Now it just doesn't run this test. Maybe we have a test which is temporarily wrong, then you exit. After a few hours, once you have done your work, you should go back and remove all the X's. It's definitely not a good style to write a lot of unit tests, and if something breaks, you all exclude these unit tests that don't work. That wouldn't make sense. Get the idea? Good. But for us, that's okay, because we can take a look at that one a little bit later. Now, let's write a little bit of code. Only a very little bit. Let's say we have, what do we do? Let's say we do a paragraph, and here we do a label, and this label says, no, not for, just say label, and we make it very, very simple. We say radius, good, and then we have a button which says calculate, and in the middle we have an input, type, number, and that's it, and here we do a break, and down there we have another paragraph which says the result is, let's do a span here, result. Let's do a little bit of data binding. The radius should be written to a variable which is called ngModal radius, and the calculate button should, if we click on it, do a calculate. There shouldn't be anything in that code that makes you wonder, hey, what is that? You should know what ngModal is, you should know what this interpolation is, you should know what an event binding is. Okay. If we run this, we immediately get an error. In the unit test, we don't need to run the software. It says, can't bind to ngModal since it's not a known property of input. Most of you had this error. In an exercise, maybe even in the exam, do you know what we did? What did I miss? An import, exactly. So we go to the modal here and import what? Do you know it? Forms module, right. The forms module, and the forms module, either you copy it from my slides or you say forms module from @angular/forms. Good. So if I run this again, our unit test still fails. Why? What's the problem? We just added forms module. We still get this strange error with can't bind to ng modal. It becomes even stranger if I say npm start. So if I don't run the tests, but if I just run the application, it will work. We will get different errors, but the ng modal will work. Believe me, we don't need to wait for that. It's really working. The point is, and this one is a little bit tricky to understand. For Jasmine, if you want to test Angular components, you need to set up a separate module for every test suite. Oh, again. Typically, we specify our module in the app module TS file. That's the module for the whole Angular stuff. And we learned together that we have to add the HTTP client module, and we have to add the forms module, and a lot of other modules if we want to use other modules. However, for tests, we have a separate module. And this module has to be defined in every test suite. Does anybody have an idea why? Why does that make sense? The answer is mockups. Can you remember what we did before with the spies and so on? Imagine that you write an Angular component that accesses a service in the background with HTTP client. If you run the tests, the service might not even be there. It doesn't run. Maybe you don't have internet access. Maybe you are sitting in the train and you're offline. How should you call the service when running your test? It simply doesn't work. And that's the reason why we have a separate module. Because this module is for testing only. This module is set up and configured with mockups. So it doesn't really run dependencies. Do you get the idea? Approximately? It's okay if you don't understand all the implications of what I tell you now, but you should have a rough idea what I'm talking about. So therefore, I have to add the imports here too. So what did we import? I think it was the forms module, right? Good. And if I run it again and take a look what's going to happen with my tests, scroll down. Oh my God, they are succeeding again. That's exactly what I wanted to have. Get it? Good. Nice. Now, let's fix the app component stuff. Let's add radius. Let's say the default value is 1. What else do we need? The calculate method. Calculate, something like this. Good. Calculate method. And the result. The result is a number, but it starts undefined. Good. What should the calculate method do? Well, it should calculate. How should it calculate? Using our service. So what we do is we just say constructor, exactly the way as before, private calculator. It's the circle math service that we would like to have. Remember, this one is exactly the same that we had before. It's just constructor injection. Good. This.calculator, this.calculator, dot calculate circle area, this.radius, and the result should be in this.result. Let's give it a try. Localhost 4200 and calculator, and the result is pi. And if we have 4, the result changes. Woohoo! Our code runs. Good. But how can we test it? How can we test that if we click on the button, then the result is written down there into the span? Get the idea? We can test it. We can definitely test it. And if you take a look at what Angular has created for you, you see it here, how this is done. And if you are interested in how you exactly do that with the buttons and so on, check out the homework. Because in the homework, I have exactly that example, and you will not need to write the test, but you need to understand and read it and fill in the blanks accordingly. As I said, this part, testing Angular components, is not part of the exam. Only the first basic part. Good? Nice. Thank you very much. See you in 2 weeks.